I'm going to give up, in essence. Because you're selling yourself short. Because while I'll say that you are the strongest out of those 10 years, I will also say that you have the lowest confidence out of them all. And I say that because I have people coming to me asking whether they should take Algebra 1 or pre-calculus next year who are sitting at an A or a B. If you have an A or a B in my class, you've earned that. I am not an easy teacher where you can get an A or a B just for showing up. But we have this belief that we've always struggled in math. We have this belief that we can't do math. And I will tell you that you're wrong. Again, coming from somebody that understands the mathematical background, coming from somebody who has taught and tutored, I don't even know how many, it has to be over 1,000 at this point, students between here and Cochise College. You are capable of getting this, I promise you, but you have to give me that effort. This is probably the hardest topic that we've covered. I will give you that. And what makes it hard is you've never seen anything like this before. You've never seen an operation that has a word on it. Not a square root sign, not a plus sign. It's a word, right? And that freaks us out. It's weird. And that is okay. Okay? It's okay to have questions. It's okay to struggle with it. It is not okay to stop. Because like I said, if you stop, I can't help you. So before we head into the warm-up, what I want to do, because you have your warm-ups out, this is where I would place this information. We're going to break down the solving, because I can't stress this enough. Even if you don't understand what a log is, solving is very routine. It's do this step, do this step, do this step. Do this step, do this step, do this step. You just have to identify where you're at. So what we're going to do is we're just going to break down the steps one more time, nice and condensed. It's not going to be a full-out lecture. Just nice and in the center here, right next to your warm-ups. We're going to write this down. And then we'll go through the warm-up and I'll do a problem off of your assignment. But this is your goal, is that when we go through this time, we increase our confidence by asking the questions. If your question is, I don't understand what you're doing, then that is at least a place to begin. But do not wait until I get to the end of a problem and tell me you did not understand the entire thing. Because if you didn't understand the first step, I guarantee you're not going to follow me the rest of the way. So if you don't understand the first step, that's when your hand goes up and you say, I don't get that. Because we have to build from somewhere. But guess what? The hand that goes up that says, I don't get that, if it's the first step, not the 10, right? And we don't understand all 10. But it's the first step you don't get and you say, I don't get it. I respect that more than if you sit there and give me nothing. Because the one that raises their hand and asks the question is the one that wants to learn it, the one that's giving me something, the person that I can help. The person that sits there and doesn't give me anything, you're declaring defeat. And I don't want to see that. Okay? So, going through, again, just off to the side, we have two types. We have solving, so our steps for solving are exponents. Your exponents start with two different types. You have the first type, and that's going to determine what steps you take. The first type is that you can make the bases the same. Now, we've been saying this for a week, but what I want to do is add something to that from what I noticed in the groups yesterday. And that is, we make the bases the same by breaking down. And we underline down. You have to break a number down in order to make your bases the same. If you can break the numbers down and you can get your base raised to some power equal that exact same base raised to a different power. In other words, this number right here and this number right here is the same number. Not the exponent. The exponents are going to be different. It's that number down below that should be the same number. If you have that, so that would be kind of step one. Step two would be to set the exponents as equal to solve. In other words, you drop the bases completely so that you can solve from there. The second type is you can't make the bases the same. It does not work. If you can't make the bases the same, then our step is to get one base on each side. And then we're going to take the log of both sides. Because if I have, let's say, b to the x equals a. So again, I made those two numbers different by doing two different letters. If I take the log of both sides, this is very formulaic. The only reason I took the log is so that in my next step, this exponent comes in front every single time. And then you can solve it from there. You cannot bring that exponent down until it is written as a log. That's why we take the log of both sides. Are we ready for the log steps, or are we still writing?
Wait.
I can erase. All right, so then the last one that we'll look at are your steps. For solving your logs. Again, they come in two different types. The first type is that they are all logs. So you would have something like the log of A plus the log of B equals the log of C. Everything has a log with it. If that's the case, you have to condense. So step one is to condense. So that you have just one log on each side. So I'm just changing the numbers because you might change numbers as you condense. So the log of some number equals the log of another number. And this is the exact same thing as when we had the bases. If I have the same bases, exponents are equal, or sorry, same bases, we set the exponents equal, right? Same logs, we set the arguments equal. You get to drop the log. And then you can solve that. Your second type is that you have a number or more without a log. So this might look like log of A plus log of B equals C. In other words, now I have something that doesn't have a log associated with it. Then your task is to make it look like the log of some number equals your number. In other words, you want the log of something equals something. And then once you do that, you get to switch it into an exponent. And it looked like from yesterday, this is where we kind of get tripped up a little bit. So let me rewrite this using words. Okay? You're going to start with the base, always. So whatever the base of the log is, that's what you start with. The power of that base is what your log was equal to. It's the answer. And you need to be equal to the argument. I have one more way to kind of help you with that, but we have to get into an example before I can show that to you. Okay? So using these, we're going to go through the 3 examples that I gave you for your warm-up, and then like I said, I'll just randomly pull, unless you want to see one in particular. I'll randomly pull one from your assignment last night on the logs. We'll go through that. Like I said, this is your chance to speak up, show me that you care, show me that you want to get it, okay? And if it's just, I don't get it, that's a step, okay? Can I erase this? Okay, so going backtracking to our first example, we have e raised to the x plus 1 minus 1 equals 2. I am starting with an exponent, yes? All right, do I have my base all by its little self? What do I have with my base? Plus 1. So I heard plus 1, and then I heard the minus 1. Careful. The base is e, yes? That plus 1 is in the exponent, yes? So this whole thing, as chunky as it is part of the base and the exponent. Make sense? We're good? So what am I getting rid of? The negative 1. How do I get rid of the minus 1? Questions so far with that? All right. Now, we're going to do one thing different than where our steps were. Because at this point, is there any way I can make the 2.72 blah, 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 blah be 3? No, I can't even break down 2.72 blah, 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 right? I can't do a factor tree on that. Does that make sense? Now, instead of taking the log of both sides, I'm going to take the ln. And the reason is going to go back to the first 2 problems that I gave you that everybody was kind of battling on because we didn't really want to go through those properties. But this is why those 2 problems were important. Okay? So, first and foremost, what is the base of every single ln? The moment you see ln, what's the base? E. So let's write that down. So I have a base of e, and inside of the argument, I have a base of e. Yes? So they match. Yes? So then, what is my result?
1.
Almost.
X plus 1.
X plus 1. It's the whole exponent. In other words, if your bases match, it simplifies to just whatever that exponent was. Good with that? Alright. Now, ln of 3, I have no idea, right? So I'm going to go to my calculator. And I'm going to do the ln, oops, not 5, the ln of 3, close my parenthesis, I get a decimal. And I'm not going to round that from my calculator. In other words, I'm never going to let that decimal leave my calculator. If you round it, it's okay to round it on your paper, never round it here, otherwise your answer will be off. To get epsilon, we minus the 1, which means that now I have my ln of 3 and I'm going to minus 1. That gives me, if I round, if I can get this to show, of 0.098, well, so let's do 0.099, rounded 3 decimal places. I'm not sure where they told you to round. 4. Questions on number 1? Like I said, why did I do ln instead of log? Because it was a base e. Every single time. If it's base e, we do the ln so that we get to drop everything except for the exponent. Questions on number 1? Because again, if you're not asking questions, you're telling me you can do this tomorrow.
Can you just say that the e's just cancel out?
I prefer simplify out because it's not quite a cancellation.
What if the e was like a 3 or something?
Then
a
it
number?
wouldn't work. You'd have to actually take it in and calculate. So it would be like my next problem, except an ln instead of a log.
Okay.
All right, number 2, please. 8 raised to the n minus 2 is equal to 24. Now we were asking, can I make the bases the same? But we didn't really stop and pause for a second on that. When we ask, are the bases going to be able to become the same thing? We have to break them down. So if I break 8 down in the factor tree, I get 4 times 2, and then I get 2 times 2. Yes? So 8 is 2 times 2 times 2, which is 2 cubed. Good so far? Now 24, if I break that down, I get 6 and 4. 4 is 2 and 2. 6 is 3 and 2, which means I get 2 times 2 times 2 times 3. What messes this up for me as far as making bases the same? 3. There's a 3. Yes? Did I have a 3 up there? No. So can I make the bases the same? Nope. Does that make sense? Does that help clarify for those of you who weren't? Because some of you yesterday had 8 and 4. And we're saying, I can't make the bases the same. What do you break 4 down to, though? 2 and 2. So you can make those bases the same. Okay? You have to break it down. You can't bring them up. You have to break them down. Okay? Questions with this so far? All right, because the bases will not become the same, we take the log of both sides. That means this is no longer 8. This is the log of 8. It's no longer 24. It's the log of 24. Whatever that decimal is that my calculator tells me. Now, the whole purpose of taking the log of both sides to bring the exponent down. That exponent has 2 pieces, so that needs to go in a parenthesis. Questions so far? Like I said, if you're not asking, you're telling me that you got it tomorrow, or the bad one. All right. Now, I would not distribute. That's going to make your life harder. So I would get rid of the log of 8. Log of 8 is timesing by the parenthesis, yes? So I have to divide. You cannot divide by just 8 or just log. This is one little decimal number that I'm going to plug into my calculator in a second. So you have to divide by the whole thing. All right, so then I come over here. I take the log of 24, close my parenthesis, divided by the log of 8, close my parenthesis, and I get this decimal here, 1.528. Again, rounded on my paper, not in my calculator. Yes?
Can Can you like put it into like a fraction on your calculator too? Would that be the same?
What fraction?
Like.
Because you
like-
cannot do the log of 24 divided by 8, no.
you
Is
can't
that
put
what you're asking?
Well, yeah, because on my calculator you can put like the fraction and then put log of 24 over
Log of 8? Then that should be fine. Try it and see if you get the same decimal. If you get the same decimal, then yes, you can.
Okay.
Okay? All right, but again, the key is do not round that. Plus 2. Plus 2 on my calculator. Notice how when I say plus 2, it has A and S there? That's what you want, because that means it's not rounding it. Okay? That gives me 3.528. On this one, it wouldn't matter as much. On the ones for tonight, it does a lot. Okay? Questions on 2? Can I erase 2?
It doesn't give me the same answer.
Then you're good.
Right.
All right, number 3, last one. 2 times 5 to the 2x is equal to 150. What is wrong with this problem? Yeah, and you had the same idea. The base is 5 to the 2x, yeah? Is it alone? No, because it has that 2 there. Now, I can't times these bases together because the 5 is tied up with the 2 to the x, or 2x power. Make sense? So I need to get rid of 2. If 2 is timesing by the 5, how do I get rid of it? Sorry, my 2 came out weird and then I tried to fix it and then it just got worse. Alright, we're good? Now 75, if I break it down, would be 3 and 25. 25 is 5 and 5. Can I make that base the same as a 5?
No.
No, because this 3 kind of messes me up. Which means what do I have to do? Log both sides. Are we good so far? Questions so far? All right, now what? Not quite yet. Exponent down, good. Now you can divide by the log of 5. So going to my calculator, I'm going to take the log of 75 parenthesis divided by the log of 5 parenthesis, and you should get about 2.683 rounded on my paper, not on my calculator. To solve for x, now I divide by 2. And I get 1.341 as my answer here. Questions with 3? All right, take out your assignment from last night. The random problem that I was thinking of is 49. Are you good with that? If I'm starting with a log, remember ln is a log, then you have your question. Does every single number have a log with it? No, because 14 does at least, right? Are we good? So if I don't have a log with everybody, then what I have to do is get the log all by itself. Now remember, logs come with bases. This base is not being shown. What is it? E. And arguments. The word for the log, the base, and the argument are all treated as one unit. Which means what are the numbers that I have to get rid of if I want that unit to be by itself? 7 and 2. I heard that from 2 people. Does everybody else follow where they pulled? Are we good? So how do I get rid of the 7? Because that's where you start. 7 was being added, so we'd subtract it. Now, this is 2 times the ln, yes?
I got them too. Divide by 2.
Are there any questions there? Are we sure? All right, now what I feel like is we can get to there, but then we kind of are still tripping up when we try to go into exponent form, right? Because your option is you either have the log on both sides and you can drop the logs, or you don't and you have to rewrite it as an exponent, which means you have to start with the base. So what's the base? E, because the ln's not showing it. So that's where I begin. I start with E. Now I promised you a secondary trick to remember which goes where. Are you ready for it? This x is the argument. It cannot be the exponent, which means 7/2 is your exponent. Your argument is what you equal. Make sense? So again, if you have E can't be to this power, not inside of a log. So it has to be to the 7/2 power.
I don't understand.
This is the argument, right? So let's do one I can actually look at. If I have log base 3 of 9, right? So we're kind of straying from this for a second. Are we good to here? This log is asking you 3 to what power is 9? 2, right? So my answer would be 2, right? In other words, the exponent of the 3 was my answer. The 9 is what I should have gotten when I raise it to that power. So if I'm looking here, this negative x cannot be my exponent because it's what I'm trying to equal, which means the 7/2 has to be the exponent. Okay. Now, e to the 7/2, I have no idea, right? So I have to go into my calculator. My E button is right above the ln, so I have to press my second button to get there. Once you do that, here's the key. Do not do 7/2 first, round it, and then plug it in. Plug it in as 7 divided by 2. And that's no matter what weirdness is there, because tonight they get kind of weird. So that gives me rounded 3.115. Divide both sides by -1. I get negative 3.115. Questions on the 49? Huh?
I can't plug that in my calculator.
Did you throw the exponent in parentheses?
My calculator is weird, like, to do log 5, I did 5, then log.
Oh, it shows you answers as you go. So actually, it's a little bit easier. You can do 7 divided by 2 equals, and then you have to do your. All right. You have a little bit of time, so we're going to grade this tomorrow, but here's the deal. We're quizzing tomorrow. So please, 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 please staple your papers before you come. It's all of this solving is going to get turned in tomorrow, which means if you've gone on to multiple papers, please staple those because that takes about 5 minutes every time we have to staple in here. And I'd rather you use that time on your quiz. Okay, so either staple before you leave, but staple before you get here tomorrow. We will grade and turn in without any questions being asked. So that means that right now you are working so that you can ask all of the questions that you need to so that you can feel good about going into tomorrow. Okay? Did that help? Like, are we feeling a little bit better at least? Like maybe up maybe 1 number, if not 2? All right. So again, call me over if you need me. I want to see you working. I know it's not a lot of time, but you still have time to work, ask questions, and make sure that you can finish this for tomorrow. Yeah. All right. So working.
I know. That's driving me insane. No.
You said it exactly what she said.
Oh no, she was saying that. Yeah, a little bit. Yeah.
Like maybe 3 minutes. I was like 4 hours. I was like, you know what? No, I didn't. I wonder if